Okay, let's start, guys. So, just to give a recap, yesterday, what we have discussed? We have discussed about standard normal distribution. Agree? Uh, if I just, yeah. So, if I just give you a recap of yesterday's what we have done, so we understood normal distribution. From that, we understood standard normal distribution. Sorry, standard normal distribution, which is a special case where mu equal to 0 and standard deviation equal to 1, always fine. And then we also see, so if you want to convert normal distribution into standard normal distribution, we can do that. But for that, we need to calculate the z-scores. Okay, for every value from the normal distribution, we need to calculate its corresponding value of standard normal distribution, which is called as z-score. Okay, and now because the values are fixed over here, fine, we can also use z tables. Okay, we can also use z tables, fine, which will directly give you the CDF, okay, or area or probability. Agree? Good till here, right? So then we have also, I also show you the example where you can convert a almost near normal distribution into a standard normal distribution. Fine, fine. So after that, we have also seen using this table, you can try to calculate the probability or CDF or area between any 2 points. Okay, between any 2 points. Okay, I think we are good with that concepts. Fine. So today, so before that, any doubts about standard normal distribution, guys? We are okay. I think we are good with standard normal distribution. Agree. So now we are going to see an important formula regarding normal distribution. Okay, regarding the normal distribution. Fine. So first we are going to see its application in the normal distribution, and then we will see it's same thing what happens with the standard normal distribution. Okay, it's a general formula. It's a general formula for the empirical. This empirical formula is a general formula for the normal distribution, guys. Okay, it's a general formula for the normal distribution. But as I said, whatever that applies for normal distribution will also apply for standard normal distribution, because standard normal distribution is just a special case of normal distribution, right? So this will apply for also standard normal distribution. Okay, then we will see if we apply this, what important thing we are able to get. Okay, we are going to see. And then we are also going to answer the question which Megan has asked yesterday, right? So why we are almost taking 3, what happens if it is greater than 3? Okay, so with that, you will have a complete picture of understanding. Okay, let's start. See, guys, empirical formula says, okay, observe carefully. Empirical formula says in a normal distribution, okay, in a normal distribution, if this is a data, okay, if this is a data, you don't know what is this data, fine, but only thing you know is it follows a normal distribution. Okay, so if this is a normal distribution, according to empirical formula, you can say 68.27, okay, out of whole data, 68.27, okay, roughly 68% of the data can be found between one standard deviation. Now, what is one standard deviation? See, this is normal distribution. Okay, we are not going into standard normal distribution yet. Okay, just for a moment forget about standard normal distribution, because it's always helpful. First you should see a general application, then you can go to specific application. Okay, fine. So in general, so that's why here if you see, we have written it as mu. Because why? Because we don't know what will be the mean of a normal distribution. It could be anything. Fine. Only if it is standard normal distribution, then you can directly put 0, 1, 2, 3. Okay, but here this is a some normal distribution which can have any mean, any standard deviation. Okay, fine. Is my voice audible? Just checking.
Yes, sir.
Okay, fine. So see here, we are having mu, some mu. It's a normal distribution. And as I said, when we say one standard deviation, that means what? Mu plus rho, mu minus rho. Fine. This distance is called one standard deviation. Okay. Mu plus rho, mu minus rho. Agree? And yeah, and this distance mu plus 2 rho, okay, and mu minus 2 rho is what? Two standard deviations. Two standard deviations. Okay. And mu plus 3 rho and mu minus 3 rho. Okay. From here to here, from mu minus 3 rho to mu plus 3 rho. Okay. This is called three standard deviations. Okay. Three standard deviations. Now, according to this formula, 68.27 or roughly 68% of the data will be found between, okay, one standard deviation. Okay, one standard deviation. Agree? 95% of the data roughly can be found between two standard deviations. Two standard deviation. And roughly 100% of the data will be found between three standard deviation. Getting? You don't know what are the actual values of the data. It could be, as I said, it could be, let's say, salary. Okay, income, salary. Fine. So it is having some values. Okay, we don't know what are the actual values. We don't know what is the count of length of this column. For example, let's say it is 1000. There are total 1000 values of this salary column. Fine. And there are different kinds of values. I don't know. Some could be 25,000, 30,000, 80,000. I don't know. Fine. But the only thing I am assuming is if this column, okay, if this column follows a normal distribution, that's the only requirement. Okay. If this column follows a normal distribution, then I can simply say, 68% of this data, okay, 68% of this data will be found between one standard deviation. That means what? If I just know if this is a distribution, if I just know mean equal to, let's say mean equal to, for example, for simplicity I'm taking 100, okay, and standard deviation equal to 10. Okay, just I know these two parameters, mean equal to 100, standard deviation equal to 10, okay, of this distribution. So using this formula, I can simply conclude that what is one standard deviation, guys? If mean equal to 100, standard deviation equal to 10, can you help me with what is one standard deviation? What will be the range of one standard deviation? Yeah, I need to answer someone.
100, 100, 100, 110.
Hmm? No, what is one standard deviation distance, guys? From where to where? From where to where we can say it is a one standard deviation.
Mu minus rho to mu plus rho.
Correct. So what is mu minus rho and what will be mu plus rho?
90 to 110.
Correct. Right. So it is mu minus rho is 90 to 110. This is one standard deviation. Others, what happened? Is it clear? Or if you know and if you are quiet, that's fine. But if you don't know and if you are quiet, that's a problem. Is it clear or any confusion? One standard deviation distance. Okay, fine. I hope that's clear. Okay, so now 90 to 110 is a one standard deviation, mu minus rho mu plus. So I can say whatever be the values over here, if mu is 100 and standard deviation equal to 10, so from this is one standard deviation distance. So 68% of the whole data, that means what? What is 68% of 1000? It is roughly 680. Agree? 680 values. Okay, out of this 1000 values, 680 values are between this range, 90 to 110. Okay, 90 to 110. Fine. Actual values, 680 values among this will be are present between 90 to 110. Means what? It could be 93, 94, 95, anything. Fine. And then what is two standard deviation? It is mu plus 2 rho. That means what? 100 plus 20, 120. Fine. And 100 minus 20, 80. Agree? So in this 80 to 120, 80 to 120, 95% of the data can be found. And what is 95% of 1000? 950. Agree? 950. So 950 values are found between 80 to 100, sorry, 110, 120. Okay. And if it's a three standard deviation, what is three standard deviation, guys? It is 130 minus, okay. And this is 70. Agree? And here almost 100% of the data is found. Agree? So obviously you can see the importance of this in a way that even though you don't know the actual data, because most of the time you will not have a chance to see the data, you'll just have these parameters. They will say, even in yesterday case also, just to give an example, even in yesterday scenario also, if you saw when we are trying to solve the example, okay, they have just said what? They just said the light bulb is, if I just show you, yeah. So for example, here also Ravi scored 980, okay, and mean test score is 870, standard deviation is 120. Fine. They just told you, and it follows a normal distribution, but what are the actual values of normal distribution? We don't know. They're just saying mean and standard deviation. They're going to give you. What are all other values of the normal distribution? We don't know. Even in this scenario also, a light bulb is lasting for 900 hours, okay, and with the mean is 900 and standard deviation is 80. And he's saying the bulb, assume it is a normal distributed. But if it is normal distributed, what are all the other values of normal distribution? We don't know. Okay, will not be given most of the time. Only mean, standard deviation, okay, and some random value. Similarly, in this scenario also, we don't know what is the actual values of all the other values of this normal distribution. But if it is mu equal to something and standard deviation equal to 10, for example, we can easily conclude that 68% of the data can be found between 90 to 180 values, 95 between two standard deviation, that is 80 to 120, and almost 100% of the data can be found between 70 to 130. So obviously you can have a clear picture, or at least rough picture in your mind, about what type of data or what range of data you are handling. Agree? Because with mean equal to 100, standard deviation equal to 10, there are so many values that are possible. Fine, there are different types of ranges that are possible. Okay, but if you want to know how much data, okay, or at least what type of range of data you are handling, fine, using this simple formula, 3 row, okay, if you say 3 row, that means in 3 standard deviation for a normal distribution, almost 100% of the data will be found. Okay, so you can just replace mu plus 3 row, mu minus 3 row, and whatever the values you get, you can at least have an idea that the minimum range of the data, whatever be the values in between, but the minimum it will be 70 and maximum it will be 130. Fine. You cannot find values greater than 130 or less than 70. Okay. Also, if your 95% of the data will be between 80 to 120. Fine. For example, let's say, to just give an example, let's say in Corona time, fine, in Corona time, okay, you are having what? So it's a emergency situation and there was no vaccine yet invented, right? So there, even because the what was the virus was also constantly changing its shape and form, so that it is very difficult for the scientists to okay invent a specific type of vaccine. Fine, that was a delay reason for the invention of the vaccine, right? So let's say they have invented a particular vaccine and they want to experiment. Fine, they want to experiment on some data, okay, on different age groups, okay, on different age groups. Fine, and if assuming that different age groups follow a normal distribution, fine. So what they can do is if at least they want to have 95% of confidence, fine. So they can take roughly this scenario, okay. That means what, among the distribution, okay, among the distribution they can say mu minus 2 rho, mu plus 2 rho, okay, from this, even though they don't know the complete what all ages it's considered, okay. So if they just know the mean age and its standard deviation, that means how much small spread it could be around the mean, they can consider just this formula, that means two standard deviations, mu minus 2 rho and mu plus 2 rho, okay, distance, fine. And from here they can conclude that in this mu minus 2 rho and mu plus 2 rho, which is two standard deviation distance, fine, I can assume that 95% of the data can be found between that, okay. And if my vaccine works well for this 95% of the data, if not 100% of the data, at least 95% of the data it is working well, then at least I can proceed for the next step, fine. So at least you will have an idea what type of data, what is the range of data you are handling. Is it very big, is it very small, am I working, because your approach will be different when you work with the data which is very small, like let's say all it is just between 0 to 1, that means all decimals, okay. Even though you have 2 lakhs values, but if all of them are 0 to 1, obviously you will have a different approach to like solve this type of problems, right? But if your range is very high, that means what, if you're working with some every the minimum value is itself 1 lakh, okay, and maximum value is let's say some 10 lakh, okay, then your approach will be different, the way how you want to handle this, or whether you want to do scaling or all other things will come into picture. So first of all you should have what type of data, what is the range, what is the values of data you are handling with, okay. For that you can use this empirical formula, and just by if you're able to do like mu minus 3 rho to 3 rho to mu plus 3 rho, what are the values you are going to get, those will be the range of your data. 99.99 point, sorry, 99.73 means almost 100% of the data can be found between these ranges, okay. This you are doing without actually looking at the column, you don't know what is the column, but just if you have these two values you can conclude that almost 100% of the data can be found between mu minus 3 rho to mu plus 3 rho, okay. That's why 3 standard deviation distance is very important, okay. So what we did not have nothing, we just had mean, and from there 1 standard deviation, 2 standard deviation, 3 standard deviation, that's it. And using this formula, 19% of the data, okay, 19% of the data can be found between 3 standard deviation distance. Is that clear? Any doubts?
No, sir, no doubts.
Okay, fine. But the formula is fine, okay. I hope formula is fine, application is also fine, it is useful. But the important question is why it is happening like that, okay. That we need to understand. That it's okay, we are having a very important formula, but there should be some intuition behind this, right? Why it is happening like that. And we already have something called a standard normal distribution, okay. We already have something called a standard normal distribution, okay. We'll try to use this case and understand why this formula is working like in this way, okay. How you can, okay, how you can, let's say, reinvent this formula, okay. We can simply do from the standard normal distribution, okay. But before that, if I just tell you, if you just try to apply, okay, if you just try to apply this one to standard normal distribution, what happens, guys? In case of standard normal distribution, what all these values will become? Mean will be equal to 0 and standard deviation will be 1, okay, 1. So directly it will become 0, 1, 2, 3, minus 1, minus 2, minus 3, okay, minus 1, minus 2, minus 3, okay. This got directly converted to this way. And here also same rule applies, okay, 68, 95, 99.7. But here the difference here is, because it's standard normal distribution, Okay, we also know that 99% of the data is found between what? Between 3 standard deviations. That means mu minus 3 rho to mu plus 3 rho. Okay, but in case of standard normal distribution, what are this mu minus 3 rho? It is minus 3. Okay, and what is this mu plus 3 rho? It's plus 3. Agree? That means minus 3 plus 3. So it is extremely useful when you think think that 99% or if it is standard normal distribution, 100% of the data is clearly can be found between minus 3 to 3 itself. These are actual values, because here I'm saying 99% of the data is found between 3 standard deviation. That means mu minus 3 rho to mu plus 3 rho. But what are mu and rho? I don't know, because if mu is 200 and standard deviation equal to 50, it will be some values. The range will be something. Okay, but still the formula works. Whatever be the mu and rho, 100% of the data will be found between mu minus 3 rho and mu plus 3 rho. That's 100% applicable. But what is that range? It will change as long as mu and standard deviation are changing. So this range will also change. Okay, but in case of standard normal distribution, because we know mu and standard deviation, fine, the values will be minus 3 to 3. Fine, mu minus 3 rho, mu plus 3 rho. So which means that 99.7 or 100% of the data in standard normal distribution can be found between this minus 3 to 3. That means this area. The whole area what we are seeing, fine, that comprises of almost 100% of the data. Isn't it interesting? Because if you have a normal distribution, we also saw how you can convert it into standard normal distribution. Fine. And once it is standard normal distribution, the ranges will be what? Minus 3 to 3. Okay. The minimum value and maximum value will be minus 3 to 3. That means 3 standard deviation distance. And now this itself is useful, okay, in yesterday's class, because you can directly get the probabilities. But now one more useful point is, if it is standard normal distribution, you can directly say that almost 100% of the data can be found between minus 3 to 3. That means what? Every value in a standard normal distribution should be less than minus 3, sorry, greater than minus 3 or less than 3. You cannot find, there is almost 0.3% chance to find any values outside this. Okay, or roughly you can say 100% of the data is found between minus 3 to 3. That is the reason we don't go to 4 or minus 4. Okay, because there is no possibility to have plus 4 or minus 4, because there is no data left. 100% of the data is captured between this minus 3 to 3 itself. Okay, is it clear, Meghna? Did that answer your question now?
Yes, sir.
You understood, right? Because we cannot have minus 4. Okay, you can put as minus 4, but there is no data what to have here, because complete 100% of the data is captured between minus 3 to 3 itself. Okay, fine. So that is fine. But now we'll also try to understand how this is working, why this is working. Okay, and we can simply do that, because let's see here we are having it's a standard normal distribution. So now in yesterday's case, from yesterday's discussion, can you just tell me? Okay, we'll directly prove this. Okay, using Z table. It's very simple. You see, can you just tell me what is a probability? Okay, if this is standard normal distribution, I'm saying standard normal distribution. Fine. Now, what is the probability to find a value between? Okay, if I just say to find a value that is x less than or equal to 1, what you will do, guys? What you will do? Or at least what is the area? That is this area, right? X less than or equal to 1 means this area at least. Do you agree? Everything less than 1. Agree? And if I say x is less than 0, if it is x is less than 0, that means this area. Agree? So now what we need to do here is, if I ask you what is the probability, okay, or what is the area between, or you will calculate area, but the question will be, what is the probability to find a random variable between 0 to 1? Okay, that means 0, okay, less than or equal to x less than or equal to 1. Okay, this area. How you will calculate? First, you will calculate x less than or equal to 1. Okay, then you will calculate x less than or equal to 0. Okay, if you subtract both, you will get 0 to 1. Agree? Fine. So those values from where you will get, you will directly get it from the Z table. Fine. So if you see the Z table, okay, if you see the Z table, fine. So here we are having what is x less than or equal to 1. So first let's calculate x less than or equal to 1. That means you will get this distance. Okay, this distance you will get. Fine. So what is x less than or equal to 1? So if you see 1 is 1.0, so it is 0.84. Agree? Agree, guys? 0.84 is a 1. That means what is 1? That means x less than or equal to 1 means this whole area. Okay, this whole area. Okay, that is 0.84. Okay, and now if you see what is x less than or equal to 0. Fine. This area I want x less than or equal to 0. What is x less than or equal to 0? 50. 0 is 0.0. 0, 0, 50, 0.50. That means what? This distance is 0.50. Fine. So now what will be this distance? (0.84 minus 50). Agree? Following. So it will be 0.84 minus 0.50. How much it will be? 0.34. Fine. So this is 0.34. Okay, this is 0.34. What is 0.34? This value. Okay, the probability or the area between 0 and 1. 0 and 1 is 0.34. Are we good till this point? Did you understand why 0 to 1 is 0.34? Or is it clear, guys? Why it is 0.34?
So
Okay.
can you repeat again?
Yeah. See, what I'm saying, I want to calculate. First, let's see what is the theory this empirical rule is saying to me. It is saying from -1 to 1, 68% of the data will be captured. It is what it is saying. Okay, let's try to prove that. Okay, what is this? What is the 68% of the data? It is from what? Okay, let me write it here. For example, -1 to 1. Okay, -1 to 1 is the area. That means what? It is -1 to 0. Okay, this area plus 0 to 1. Agree? -1 to 0, 0 to 1. This is the area. Fine, that is 68. That is what the rule is saying, empirical formula. But now let's try to see that. So first we'll calculate what is the area between 0 to 1. Okay, what is the area between 0 to 1? Fine. What is the area between 0 to 1? It is very simple, right? That means what? How you will get the area? If you calculate x is, if you say x is less than or equal to 1, you will get all this area, this complete area. Agree? After that, oh sorry. After that, when you say x is less than or equal to 0, CDFs, we are just doing CDF. Fine. Which will give, if you say x equal to 0, then you will get this one. Agree? When you subtract these two, you will be left with this one. Is it clear?
Yes, sir.
Same example. I think we have already seen this example, right? Some problem where the score was, yeah, in the score where he is scoring. If you remember, how did we do this? See, he's asking the mathematics exam score. He's asking what is the score between 45 and 65. You remember? 45 and 65 is asking. Fine. But we don't have directly 45 and 50, 65. We can calculate x less than or equal to 45. Okay, and we can also calculate x less than or equal to 65. Okay, but 65 will have 0 to 65. 45 will have 0 to 45. How you will get only this 45 to 65? Subtract these two. 0 to 65 minus 0 to 45 will give you 45 to 65. Clear? Same concept we are using. When I say 0, okay, when I say 0 over here, it will give from what? Minus 3 to 0, it will give minus 3 to, first of all, if I want to calculate till 1, it will give minus 3 to 1. And next, if I say 0, it will give minus 3 to 0. Fine. If I want to make you understand, see, this is the bar. Fine. If I say 1, it will give minus 3 to 1 because all the area less than or equal to 1. Okay. All this will be, here you have 1, here you have minus 3. Fine. You got this. After that, let's say if you're saying 0, again it will give, let's say you're having 0 here, from here to minus 3. Okay, less than or equal to 0. Okay, all this minus 3. Now, if I want just between 0 to 1, what is this? What is this piece? The above piece minus below piece will be this piece. Agree? That means what? That means x less than or equal to 1 minus x less than or equal to 0. Is that clear?
Yes, sir.
Okay. So first let's try to find out this probability. Okay. It's same. Yesterday also we have seen you can calculate probability between any 2 points. Any 2 points, right? So you can calculate between 1 to 2, 1.5 to 3.5, anything. Just subtract those two values from each other. So I want to, if I want to check what is the probability of 1, just 1. Okay, that means what? X less than or equal to 1. Okay, x less than or equal to 1. What is this? This is a CDF. That means internally what we are asking, what is the probability to find a random variable less than or equal to 1? That means indirectly we are saying what is a CDF. That means again we are saying what is the area less than or equal to 1. So if this area we can directly get from the Z table because this is standard normal distribution. Directly Z table will give you the probabilities. Yesterday we have seen the same thing. So what is over here? Now what area we want to calculate? It is 1. That means 1.1 can be calculated 1.0. So where is 1? 1 is over here, 0 is over here. So the area is 0.84. Agree? 0.84 is the area of what? Only 1. Okay, this is 0.84. Okay, that means the whole thing from minus 3 to 1. When I say x equal to less than or equal to 1, from minus 3, all this area till 1, it is 0.84. Okay, now next I want to calculate 0. Okay, x less than or equal to 0 is what? So if I go here, where is 0? 0 is here, 0 is 0.0, so it is 0.50. Okay, so now I'll go here, x is less than or 0 is 0.50. This is what x less than or equal to 0, again from minus 3 to 0, the whole thing. So if I want only 0 to 1, I need to subtract x less than or equal to 1 minus x less than or equal to 0. If I do this, I'll get 0 to 1. Fine. So that means subtraction of these two. So if I subtract these two, how much I got? I got 0.84 minus 0.34. Okay, this is 0.34. Okay, that means what? From 0 to 1 only. Okay, this area from 0 to 1. This area is 0.34. Is this clear?
Yes, sir. Clear.
Okay, fine. Others also, I hope it's clear. So,
Yes, sir.
fine. So now 0 to 1, we got how much? Just put it aside. Okay, 0.34. Okay. Now, next what we want? Minus 1 to 0. Agree? How we will get minus 1 to 0? Now, can you tell me if you understood 0 to 1?
Minus 3 to 0 minus 3 to minus 1.
Perfect. Correct. Fine. So first we need to calculate minus 3 to 0. Okay, minus 3 to 0. So that's correct. But how will get minus 3 to 0? If you just do x less than or equal to 0, that will give to minus 3 to 0. Agree?
Minus x less than or equal to 1. Minus.
Correct. So minus x less than or equal to minus 1. Okay. This value will give what? This area, minus 1 to 0. Agree? So x is, but since we are having this negative value, we need to go to, because here everything is positive only. You see, everything is positive because what? This is a positive z-score. So now we'll go to negative z-score. Okay. This is negative score. Okay. Now here, what is our requirement? First, x less than or equal to 0. So 0 is 0 anywhere. So here minus 0 or 0 is 0. So it is 0.50. Okay. So this value is what? 0.50. Okay. Minus, what is the area of less than or equal to minus 1? Okay. What is the area of minus 1? Minus 1 is, see here, this point. Can you see minus 1? Minus 1 is minus 0.15. Agree? 0.15. So this is 0.15, this area. Okay, x is less than, okay, this area. If this x is minus 1, this area is 0.15. So if you separate these two, how much will get?
0.35.
I'll show you. 0.50 minus 0.15. 0.35. Okay, so this is equal to 0.35. Okay, so now we got what? This area, what is 0.35, guys? 0.35. 0.35 is minus 1 to 0. Agree? And 0.34 is 0 to 1. Do you agree with me for this?
Yes, sir.
If you add these two, how much will get?
0.69.
0.69. Okay, which is very close to 0.68. Okay, because it is 0.68.27. Because if you consider the actual values, okay, if you consider what is minus 1 actually, 0.15866. Fine, we have assumed it as 0.15. But if you take 0.15866 exactly, and then over here, what is 1? 0.84134. We have considered it as 0.84. But if you take 0.84134 till the fourth decimal, fifth decimal, you will get it as 68.27. Okay, but roughly you can take it as 68 or 69. Okay, so let's say it is 69 if you take the exact values. So now we have clearly practically seen that 68% of the data, okay, is found between one standard deviation. Agree? Between this one minus 1 to 1, which is one standard deviation for standard normal distribution, guys. Okay, 68% of the data is clearly found, which we have clearly seen. If you want to extend this, okay, once we have proved the empirical formula for the standard normal distribution, you can clearly go and prove it to the, but here you cannot say in standard normal distribution, you can say it is between minus 1 to 1. Here you cannot say minus 1 to 1 because you don't know mu and rho. You will say from mu minus rho to mu plus rho, that is from one standard deviation. You will use the term between one standard deviation, same data, 68% of the data will be found. Okay, whatever be the distribution, whether normal or standard normal, 68 should and must be found between one standard deviation. 95 should and must be between two standard deviation. 99.7 should and must be between three standard deviation. Agree? But the only advantage of standard normal distribution is you will have the actual values because you know mu and rho. Now you can simply conclude from minus 1 to 1. Okay, whatever be the data, if it is standard normal distribution, from minus 1 to 1, 68% of the data is found. From minus 2 to 2, 95% of the data is found. And minus 3 to 3, 100% of the data almost is clearly found. So I've shown you how to calculate to 0 to minus 1 to 1 standard. You can simply extend that to minus 2 to 2. Okay, you can directly take, okay, you can directly take x is less than 2 and then you can separate from x is minus 2. Okay, this area, that area. Okay, I think you are comfortable now to check the z tables, okay, and take the calculations. Okay, or you can just go through this class again, how I calculated the area between minus 1 to 1. Okay, first calculate x less than or equal to 1, then x less than or equal to 0 and separate. Similarly, you can extend to minus 3 to 3 also. Then you will get, when you do for minus 3 to 3, the area you will get, yeah, you will be equal to 99.7. Okay, So that's why I'm concluding again practically, okay, for all purposes, if it is standard normal distribution, simply you can say almost 100% of the data can be found between -3 to 3. Okay, and anything greater than here -3 or 3, okay, will be outliers. Okay, will be what? Outliers. Agree? Where did you hear this term outlier? Okay, using box plot we have handled outlier. You remember using IQR?
Yes, Santosh.
Okay, using IQR. Okay, I will show you. Okay, but before that, what is the conclusion here? If we will use a general term, we will say 3 standard deviation. Okay, so in a normal distribution, 3 standard deviation of the data can be found between 99. In a normal distribution, 99.7% of the data can be found between 3 standard deviation. Okay, and if in the case of standard normal distribution, that is also true, but you can also say one more step, that is -3 to 3. -3 to 3 is also, in other words, it's 3 standard deviation for standard normal distribution. Is the concept clear? Are you good with empirical formula? Everyone?
Yes, sir.
Yes, sir.
Okay, perfect. So, and if I just show you, yeah, so if I just show you a small calculation, okay, simple calculation itself. See guys, from here you can also try to understand few other things. Okay, very straightforward, but still I will let you know. See here, he's saying, because you should also observe that 68% between 1 standard deviation, 95 is between 2 standard deviation, but this 95% is also already including 68%. Agree? And this 3 standard deviation is also including 2 standard deviation. 2 standard deviation is also including 1 standard deviation. Okay, that means what? This is mean. Okay, this is mean. Okay, this is some normal distribution. This orange color is 1 standard deviation. That's why it is 68. Okay, if this is 68, to the mean, 34 will be one side and 34 will be other side. Agree? We also got the same thing, right? When we calculate using 34 and roughly 34. Okay, so 34 will be one side and 34 will be one side. Okay, that is done. Now, if you see in 2 standard deviation, how much data is found? 95. Okay, if this is 95, okay, or already from this part, how much it is, how much we have got? 68 we got. Fine, but I'm saying in this green color part will be 95. That means what is left over?
27.
95 minus 27. Okay, so 27. That means what? This, the whole thing, see, from here, from this part, okay, from this part, okay, this whole thing, okay, this whole thing will be 95. Okay, that whole thing will be 95. Okay, but I'm saying this 2 standard deviation is already having 1 standard deviation inside it. Okay, that means what? 60% is already gone. Remaining is 27. And if you say, that means 27, this green part is, this whole green part is this side, and this side is 27. Each side, how much you will get? 13.5. Okay, that's why this is this side 13.5, this is 13.5. Okay, so when we say 2 standard deviation, it is 95%. Okay, but how, from where you are getting? Already 1 standard deviation is comprising of 68, remaining 13.5, 13.5. So overall, if you add this complete, you will get 95. Clear? Similarly, 99.7 also. This 99.7, from where you are getting? I'm saying this is 90. This is 99.7. Okay, but this 99.7 is already in this. This is 3 standard deviation. Okay, if this is what will be this? Mu plus 3 row and mu minus 3 row. Agree? Because you don't know this standard normal distribution. You cannot say it is a 0 minus 3 to 3. It is normal distribution. Okay, but here till this green point, already 2 standard deviation distance is done. Okay, that means how much? 95% of the data is done. Remaining is how much? Remaining is out of 99.7. Okay,
2.7.
how much? 4.7.
4.7. Okay.
Okay, this violet color will be 4.7, and each side how much you will get? If you divide by 2, you will get 2.35. Agree? That means this is 2.35, this is 2.35. Fine. But if you add now everything, this whole thing will be 99.7. Okay. So when we are saving 3 standard deviation, it is already including 2 standard deviation inside it. And 2 standard deviation is already including 1 standard deviation. Okay. That is a calculation you need to do. So that's why it's called symmetry. Now you understand the word symmetry. So we heard this term. Okay. Normal distributions are symmetrical. That means to the left side portion will be equal to right side portion. And you can clearly see the distributions are perfectly same. Left side, right side. Okay. And most important thing is between 3 standard deviation distance, whole data is found. Okay. So now can you understand the importance of standard deviation? Why we are saying? Because in real world, okay, you can have thousands of examples which are following normal distribution. Okay. But if you just know mean and standard deviation, okay, just mean and standard deviation, you can come here, put mu minus 3 row, mu plus 3 row. That's it. You will have the whole picture of the data or the range of data you are working with. From that, if you want to take one chunk, 1 standard deviation or 2 standard deviation, or you can take any value, you can say from, we are taking from mu plus 2 to 2 row, sorry, mu minus 3 row to mu plus 3 row. Okay. But if you want to take any other value, okay, or from minus 1.5 to plus 2.5, any value, if you want to calculate the area, now it is just in your hands, right? Using the convert this into standard normal distribution, use as z-score, and you can convert any area between any part of this. Fine. So you can take any chunk of the data and do your experiments or have some knowledge. Okay. With the help of just 2 parameters. That is the importance of standard deviation. Okay. And now that is importance of standard normal distribution. Is it clear? Any doubts?
No, sir.
Okay, fine. So now we'll see, since we have derived, okay, and understood that 3 standard deviation, okay, 3 standard deviation is what comprising of 100% of the data. What are the applications? Okay, we'll try to see that. Okay, so now we have understood this. Fine. So as I said, symmetry is 1 point. Symmetry is 1 point which I've just shown you about properties of normal distribution. And in normal distribution, mean will be equal to median equal to mode. Okay, I've told you in normal distribution, mean, median will be and mode will be at the same point. Agree? And then empirical formula can be used. Okay, that is also agreed. And area under the graph will be equal to 1. Agree? Whatever be the normal distribution you take, the overall area will be equal to 1. And this is also proved using CDF. The maximum value of CDF in all the graphs which you have seen till now, it will be equal to 1. 4, fine. So these are the 4 properties you need to remember. Symmetry, mean equal, median equal to mode, empirical rule can be applied, area under the graph equal to 1. Fine. Now, next thing is application of normal distribution. Okay. So there are many in data science, right? So normal distribution will help you in 100 ways. Okay. So you will see that. Now, but firstly, if we try to see, there are mainly 3 concepts which it will be helpful. One is in the outlier detection. Okay, that means using this concept, you can clearly try to detect outliers, which is very practical application, which we'll be seeing. Second thing is assumptions of ML algorithms. Okay, because most of the machine learning algorithms, right, they assume that the data is normal. Okay, internally, because just to give you an idea, we are going to see lots of different types of models. Okay, at least 10 models we are going to see, from the classification, regression, okay, supervised, unsupervised, etc. Over here, there are some models, I'm not saying all, there are some models which assume that the data, input data which it is getting is a normal distributed, or the error which this model is making, sometimes that will be in the normal distribution. Okay, so that's why it is very helpful, okay, to convert the data into normal distribution. Okay, because as you can see, if once it is converted into normal, okay, once it is converted into normal, we already know almost 90% of its history we know. Okay, clearly from here. And once it is normal, I think now you can simply do it stand normal also. Okay, yesterday we have seen example, right? So you can convert into standard normal distribution using that score. Once you convert it, you know complete history of that. Okay, you can do whatever you want to do. Fine. So that's a one point. And thirdly, the application is center limit theorem, guys. Okay, which we are going to see, I think, in next class. After this, we will see few more concepts. Okay, and after that, we'll see the application of center limit theorem. Now, center limit theorem in statistics of data science is like a magical theorem. Okay, this is one fundamental theorem which is extremely helpful. Okay, and it's very simple. Okay, and it is I would say you know when I'm explaining this, it is very interesting theorem, and also it's very simple theorem at the same time, and also it's a magical theorem. You don't know why it's working, but it will work in every scenario, and it will give you wonderful results based upon simple rule, and it will use normal. It will use normal distribution. Okay, we'll see. I'll not talk about much about this, but when I'm discussing that, you will understand. Okay, and it is a basis of many applications, or it is used in many what I can say scenarios. Okay, because it is that helpful. Fine. So okay, fine. Let me not speak about much about it, but you remember. Okay, when I'm speaking about central limit theorem, you'll understand. Okay, but now we are going to see outlier detection. Okay, so as I hope we have already seen a few examples regarding the outlier detection. So if you remember, okay, initially when we are discussing, okay, I've shown you box plots, okay, outlier detection. Fine. So we have discussed, okay, these bubbles will be the outlier. Agree? That is regarding the box plot. And apart from that, I've also shown you regarding what quantiles, okay, in IQR, lower bound, upper bound, anything less than lower bound, or anything greater than upper bound will be an outlier. Did you remember these concepts or gone?
Yes, Santosh, remember.
Okay, fine. So this is one way of handling outlier. Okay, at that time, we don't know anything about normal distribution or standard normal distribution. Okay, but now since we have the sufficient knowledge about these two, using this also we can easily detect outlier. Okay, using detect outlier. Okay, but the difference is here, for to apply this IQR, okay, or box plot, there is no initial requirement. Okay, any data set you can apply and calculate these values and find out the outliers. Agree? So even if you take, see, this some data set I took, okay, I don't know what is the shape of this. It's not normal. Still it works. Okay, using IQR. But if you know that the data is normal, okay, if you know that the data is normal, you can use one more way. You can use one more way to what? Detect and handle the outliers. Okay, now we are going to see that. Fine. So now, and the concept is simple. I think I have just mentioned here, as you can see, we only understood empirical formula, and we have decided and we proved to ourselves from the table. Okay, we did not take it blindly. Formula is fine, but we have clearly seen from the table, and we calculated practically that 100% of the data is found between -3 to 3. Agree? That means anything greater than 3 or less than -3 is an outlier. Agree? So we will use the same concept. Fine. So first we will go, okay, and let me, yeah. So if you see in the iris dataset, okay, in the iris dataset, we are having what? We are having, okay, all this, okay, sepal length, better length. So yesterday for the, I've shown you this example, right? So for the sepal length, okay, sepal length, we have converted from normal distribution to standard normal distribution. We have converted how? We have converted into, we have calculated the z-score. Where is z-score, guys? Okay, x minus mu by rho. Okay, this is z-score, and we have converted into standard normal distribution, mean equal to 0. Okay, that's fine. But now let's take some other column. So I have considered better length. You can take any length. Okay, any column. Okay, so over here, if I consider petal length, okay, and using petal length, okay, so initially if I just take what's up? Okay, if I just show you the petal length. Okay, so it's roughly normal. Okay, it's a bimodal or okay, but it's roughly normal. Okay, so actually, okay, see here in the iris dataset. Okay, so you're having 4 values, right? So you're having maximum value. Okay, what your petal length is having some 11. Okay, 2.5, 6.1, 3.6, etc, etc, etc. Fine. So here, okay, if you see these 2 values, right? So 151. So actually the data was still 151. Okay, just to show you the example that will detect the outlier. So I have added these 2 rows. Okay, because the data was actually perfectly normal. Okay, so I have added these 2 rows. Okay, but you can apply to this data set also, because it is nearly normal. Okay, it's bimodal, but still it's a normal. Fine. So similarly, but you can take any other example. Okay, I'll just show you, give you a demo of this. Okay, it's very simple. So if you consider this petal length, okay, and assuming that it is a normal, fine, it is a normal. Even if it is a normal, okay, even if it is a normal, what will be the outliers? Where you can find the outlier, guys? Anything less than 3 standard deviation distance, okay, you can find the outlier. Agree? That means anything greater than mu plus 3 rho or anything less than mu minus 3 rho. Fine. Anything less than mu minus 3 rho or anything greater than mu plus 3 rho, it is for the outliers. Agree? Do you agree with me with this point? Or do you have any doubts? Because 19% of the data is present. And I'm not saying standard normal distribution, because you can convert this into standard normal. You see, you can convert this petal length into standard normal distribution, just like how we did for sepal length. And you can also do that, or you can directly do that, because this empirical formula will hold for any normal distribution, not necessarily for standard normal distribution. Okay, so we need to calculate mu minus 3 rho and mu plus 3 rho. Okay, see, this is mu. How petal length into petal length dot mean will give you what? See, we need to calculate mu minus 3 rho. Okay, and mu plus 3 rho. Okay, what is mean? Mu is petal length minus mean. Okay, minus 3 times 3 rho. What is rho? Standard deviation of petal length. Okay, and same thing, mu plus 3 rho. Agree? What are these values? These values are simple. Okay, this is minus 1.95, 9.49. Fine. So now any value less than this or greater than this will be an outlier. Okay, less than this or greater than this will be an outlier. Fine. So if I just calculate greater than 9.05, fine. What is 9.49? Okay, see, we got one row, okay, whose length is petal length is greater than 9.49, okay, which is 11. Fine, this can be considered as an outlier, or which is less than this value. Okay, this is lower, this is mu minus 3 rho, okay, or minus 1.95. Okay, if I just do this 1.95, okay, you have this petal length minus 2. Okay, see, length cannot be minus 2, this just for the demo. Okay, so this particular row is also an outlier. Okay, so using this, you can directly simply get all the outliers. Okay, if you want to do, you can also, as an exercise, you can take the iris flower data set, and you can also apply this IQR also. Okay, I hope you remember this IQR, so you can calculate lower bound, upper bound, and then you can get these values. Okay, you'll get the same values, or directly using standard normal distribution, or so normal distribution empirical formula, you can just calculate mu minus 3 rho, mu plus 3 rho. Anything less than this will be an outlier. Okay, so you can calculate this, and you can put the filter, just you'll get all the outliers, and we'll see how to handle this outlier later. Okay, but as of now, for simplicity, if you don't want outliers, you can just drop these rows and consider only other rows. Okay, so this is how you can directly get the outliers, but the concept is empirical formula. Okay, who is giving us the power to do this? Empirical formula is giving us the power. Okay, this is for the normal distribution. You can just convert this into standard normal distribution also. And then in standard normal distribution, what will be the value? Once you convert into standard normal distribution, you can directly say any value less than -3 or greater than +3 is outlier. Okay. Here we are still converting it into mean and saying this is lower bound, this is upper bound. Okay, mu plus 3 rho, mu minus 3 rho. But if you convert the petal length into standard normal distribution, okay, then you can directly say -3 plus 3 will be the boundaries. Anything less than -3 greater than +3 will be directly an outlier. Is it clear? Any doubts, guys? Is this code explanation clear?
Yes.
Yes, right. Okay. So I would say that's a simple example. So yesterday when you were searching, right? So I found this. Yeah, I found this site which was actually very helpful. Okay, so where he was using. So I'll just ping this site. Okay, so you can just have a look at it, because here he has given the example of all the three. Okay, so same concept, nothing new, but he has given you what is overview. So that's why I say, so see, when you explain the class, you'll understand the concept. Okay, you'll get almost most of the concept. Okay, but after the class, if you just go through the class once again, or regarding this class, if you go through like some top blocks, you'll at least get 1 or 2 new points, because anyone cannot cover 100% of the points. Okay, so because in the class we'll cover maximum points, but what all it is available throughout the data science, okay, it is not possible to cover in the in one class. Fine. So I would say, because you have a very solid understanding, very basics, and you will have a decent knowledge, obviously. Okay, just to want to add something on top of that, or if you want to get another point of view, another perspective, okay, so you can just go through some blocks, okay, and have a better understanding of that, because we'll get different applications. Okay, same concept you will apply to, you can apply in different ways, right? So I may teach 1 or 2 ways. Okay, and if you just go through some other like writings, you will get some other information. So that the goal is to have a 360-degree view of the concepts. Okay, so see, he is saying how to detect using standard deviation. Okay, so here standard deviation means what? Directly he's saying mu minus 3 rho to mu plus 3 rho. The upper limit and lower limit will be that. Okay. So, and he's also saying 99% of the data can be typical lie between these. Okay. So the number of outlier will be close to 0.3. Right. And the same code he will use, nothing new they will be using. Okay. And or if you don't want to do that, okay, if you want to use the z-score, that means what? Converting it into standard normal distribution. Okay, converting it into standard normal distribution. Okay, x minus mu by rho. Okay, so for that, if you calculate the z-score, you will directly get the lower limit and the upper limit. Okay, and what we are going to do, z-score for each and everything we can calculate, and anything is less than, okay, if you see, okay, if I just try to show, here we have just calculated the what we have done the normal distribution. Okay, but for the petal length, if you want to convert it into standard normal distribution, okay, how we will do, guys? We have this one, right? So we have the mean and the standard deviation. Okay, but the petal standard normal distribution will be what? Okay, so okay, petal mean will be this. Agree? And petal standard deviation will be okay. This is a mean, this is a standard deviation. Okay, and if I want to convert this into standard normal distribution, okay, assuming that this is a standard normal distribution, okay, if I just do this, what I'm doing, x minus mu by rho. Okay, I got these values. Fine. These are the values I got. And if I calculate anything, okay, okay. So for I, if I just do I, okay, fine. So if now what are these values? These are the actual values converted into standard normal distribution. Okay, if I is less than -3, okay, print I. Okay, see you got some value -3.02. Fine. And if I is greater than 3, print I. Okay, you got two values. Fine. So this is, I'll say, this is little outlier. Okay, this is positive outlier. Okay, see, same thing. Using here, we have just used the normal distribution itself. We did not want to convert in stand normal, but still mu minus 3 rho, mu plus 3 rho, the 3 standard deviation rule empirical will also work. So that's why using this only, we have just converted and saw that anything less than 3 standard deviation or greater than, we have used that. Okay, we got two values. Okay, for negative, for positive, we got one each value. Okay, but as I said, you can also directly convert the whole petal length into stand normal distribution. How you can do? Just Z score. This is application of x minus mu by rho. Okay, this will give you a petal stand normal distribution. Okay, these are the corresponding values of all the petal lengths. Over here, now because this is standard normal distribution, as I said, you can directly say -3 to 3. The minimum value will be -3, maximum value will be +3. Anything greater than this or less than this will be an outliers. The same thing I have done here. Okay, anything less than -3 or greater than +3 will be an outliers. Okay, and same two rows you got. Okay, now these values are different because these are the standard normal distribution values. Okay, but the same two rows, whatever you got over here, okay, whatever you got over here, okay, so the same thing you'll also get over there. Okay, these two values. Agree? Is it clear? The application, how the standard normal distribution empirical formulas are directly helpful in detecting the outliers. Is this code clear? Okay, I hope that's clear. Okay, so fine guys. So that's regarding the normal distribution, standard normal distribution, empirical formulas, and also the application of the normal distribution. Okay, so with this, I hope at least from my end, I covered what all that is required for normal distribution. And also, I hope that you guys also understood most of the concepts. Okay. So try to revise it. Okay. And as I said, yeah, this is the application. Fine. Sorry, just let me check. Did I miss anything? Okay, empirical is covered. Yeah, outlier detection also. I have shown you an example. Fine. Okay, good. So then tomorrow we are going to see a few things. Okay, we are going to cover new concepts called as skewness and something called as kurtosis. Okay, and then we are going to see all this is fine. Whatever we are studying is fine, but first of all, how to find out if a distribution is normal or not. Okay, so yeah, by drawing the plot you can see, but there are also every time you cannot draw a plot. Okay, so there are some other ways. Okay, because now the main agenda is, now since we studied and established that normal distribution, standard normal distribution are two heroes of statistics. So our goal will be to convert, if it is already present in normal distribution, then we are happy, lucky. Okay, if not, if we are dealing with some distribution, okay, first of all we will try to understand whether this is following a normal distribution or not. Okay, if it is following, then we are happy, we already know all the things about it, we will use this. Okay, if it is not, first of all we will know how you can find out. Okay, after that, if it is not a normal distribution, okay, if it is not a normal distribution, then our power rates get reduced, right? Because we cannot use all of this. Okay, we cannot use this all the concept which we have studied empirical, we cannot use that. Okay, but we are not fools to simply leave it like that. Okay, we will see some methods how you can convert even if it is not a normal distribution. Is there any way to convert it into normal distribution? Okay, so you're understanding, right? ఎటు చేసి అయినా we will try to a distribution అయినా we will bring it into normal distribution. Okay, because we are very fond of normal distribution now. So any distribution adjust the normal distribution laga convert చేస్తే we can have many applications. Okay, so first we will see how to detect if it is a distribution normal or not. Okay, once it is detected, then we will see if it is not a normal, how you can convert it into normal distribution. Okay, so with that, and then we will also see different types of sum distributions also. Okay, fine guys, that's all from my end. Okay, I hope the class is clear. Okay, fine, let's meet tomorrow, but don't join late. As I said, we lose some time. Okay, try to join on time. Okay, fine guys, take care.